Hey, today we're going to look at a riddle that encodes a mathematical problem. And the problem is known as Diophantus' life. Diophantus of Alexandria, to be more specific. He was from approximately 200 BC. And he wrote a lot of work on algebra, number theory, and some of the early maths notation. Here lies Diophantus. This is one of the earliest puzzles that I've found out about. My father was a maths teacher and he showed me puzzles like this. And the takeaway from the puzzles is what I'm going to talk about today, and other maths competitions as well, such as UKMT and Maths Kangaroo, for instance. I'm going to teach you basically some ideas about how to organize your thinking. So with these kinds of puzzles, we often say, think outside the box, or use lateral thinking skills. Basically trying to solve a problem in a creative or indirect way. Sometimes methods can be easy, maybe simple, but more often we have to view a maths problem in a new light. So let's have a look. You could read that there, but here is just one step: understanding. When you read it, do you understand it? Pick out, underline, circle the mathematics perhaps, or anything that you might need. So when you've identified the problem, we now have it listed out. You don't need to list it out like this. This is just to demonstrate it. So when you've done that idea, you've devised a plan, you may generate potential solutions. Interestingly, the reason why I'm picking this really is that when I was about 9 or 10, when I solved this, I didn't really have the algebraic tools, so I solved it a different way. So today we're going to do the more obvious, more traditional answer you see on the internet, so to speak, with the algebra. So we have a series of fractions and a few whole numbers. So let's put that together, okay? So the first part is where we just actually list out our variable x, we say. Our variables are here. So what you'll do next is you'll find a common denominator. 12 times 7, 2, 6. So you'll have 84. Do that in your own time. 5 and 4 we could change as well, but we'll leave them for now. Just the whole numbers of 5 and 4. You'll add all your fractions up and add up your whole numbers, and then you'll have an answer. The interesting thing about this question is that the answer is actually already in the common denominator, in the fraction, as the answer is being solved. So you could have just used whole numbers and some common sense. The multiples of 6, 12, and 7, you could actually get really large numbers as well. But we know that people, in terms of our life, 84 is probably more reasonable. The next number would be 168, which doesn't seem so reasonable. That's a question that I solved with the common multiples a long time ago. But I'm just demonstrating here today that you can just set up a little plan for yourself when you're doing questions like this, and just think about what you know already in terms of the question. I'm going to show you a more visual representation of a question with geometry in 2 minutes, and evaluate and interpret what you're doing as well. So look back over and just make sure it makes sense. Just to introduce a promotion of love of problem solving, which I have, and you can collaborate with your classmates as well. At different points during the year, there are junior, intermediate, and senior mathematical challenges of 60 minutes, multiple choice with the UKMT. You can go onto that website there and practice those questions. They have instant scores, they have step-by-step solutions, and you can develop your skills and knowledge in maths. With that, I'll be doing questions on this in future videos. A little bit more difficult, I think, is the Maths Kangaroo, where it does the same idea basically, but they have different time limits and different amount of scores for the grades. So they actually do from grade 1 to 12, but let's say grade 6 to 12 for my use here. So grade 6 and 8 is 75 minutes, whereas grade 10 would be more time. And multiple choice questions actually can be quite difficult anyway, because there might be some answers trying to trip you up. So we'll be practicing that stuff as well on the Math Kangaroo in MathMech. Here's one last example just with the step-by-step process, and we have a question. We have a shape. So check the size. It's a hexagon. We want to find the area where it says A in that hexagon in the center. We've given a total area. If you just look at this question, you might figure it out. You might divide it up and find little bits and pieces. But I would suggest you think about what you know already about hexagons. So for instance, you know it's 6 sides. If you divided it into 6 different triangles, that 216 now becomes 32 or 36. Which one is it? So when you do it out, you're going to get some kind of analysis like that. So we have 6 triangles, for instance. You could divide those triangles up again. And there's lots of different ways of thinking about this kind of stuff. Okay? So when you are doing these kinds of questions, I would suggest you don't worry about your knowledge so much. You have to build on that anyway. So if you're in grade 6, you're not supposed to, you haven't been exposed to certain things yet, certain knowledge, and that might be what's stifling you. But just keep your mind alert to thinking outside of the box, as we suggested. And on those websites, you can do worksheets, you can do online practice and online tests, and just keep working at it. And of course, maths is just practice. You just get better as you go along, and keep adding to your knowledge, and keep thinking about it. So use spaced repetition. Use spaced repetition maybe once or twice a week, doing a little bit of this, and it would be very helpful for you if you're interested in maths and in keeping yourself challenged in that way, because it really will add to how you make connections, find patterns, and use logic in maths and in other subjects too. Thank you.